going to take a couple seconds to set this up. It requires a very precise assembly. This is actually a robotic arm that will type on your computer for you. So that's really exciting, and this was a project that I sort of decided, I just think that would be a cool thing, and I don't know how I would ever do it, but I'm going to try. So, also, by the way, my name's Callie, and I'm going to be a senior at the Dalton School in the fall. So, this project is clearly a robotic arm, and it's actually a selectively compliant articulated robotic arm, which is also abbreviated as SCARA, and we won't use that. And that means that it has a lot of mobility in the X and Y direction, and just a little bit in the up and down, the Z direction. So it means that it can reach all these different keys as it needs to. It also is voice controlled, which was my latest modification, and took a really long time, but we actually found a more simple solution than writing an API to interface with Google. So I'm using the dictation thing on my Mac. This is a robot. Question mark. Press the return key. So that's how it works. It goes to each key, it navigates to it, and then this rack and pinion presses down. My piece of really cool tech, which is my favorite thing about this robot, is called inverse kinematics. And inverse kinematics is super cool. It has awesome applications. So what it means is if I want to go to a specified point, perhaps a specific key in a word, if I want to go to a key that says O, then I have to know how far away that key is from my base, from my origin, and then I'm going to use an algorithm that I wrote to figure out how I need to move my arm to get to that key. And this can be really complicated. You can do it in 3D space. You can do it with 8 different, shoulders, elbows, wrists, finger, this joint, this joint, this joint, and that requires a lot of cool math. But I can't do that, so I just did it in 2 dimensions with 2 degrees of freedom, which means my shoulder and my elbow. And so I used some trig that I learned in school, so that was exciting to actually see this would be helpful. And I wrote that code myself while consulting different websites for help. Another piece of cool tech I have is this finger. It's a really nice rack and pinion, which means it has a circular gear and then a straight line, which has like gear notches. And so it can come up and come back down and go up again as the pinion will dictate. And I thought that was going to be super easy because it's really small and it's just at the end of the arm. But actually it took me a week to figure out because I kind of underestimated it. So whenever I was telling people like, oh yeah, this whole week I've been working on this on my finger, they're like, well, why can't you just go like this? It doesn't seem that hard. And I'm like, well, you can't just go like this. That's not an engineering thing. So clearly that's also like the anticipation that I had. I thought that it would be really easy, but I tried all these sorts of different things, and this was the most reliable, accurate method. So that's my second piece of really cool tech. to look at this from a sort of big picture, I am a comp sci student at school. I've taken comp sci for 3 years. I love it to death. It's my favorite thing in the world. And I did a comp sci project here at Blue Stamp last year. I did a bike speedometer. But I thought, you know, this year I'm gonna like take the high road, and I'm gonna do something to challenge myself. So I'm gonna do something robotic, something physical that I've never ever done before in my life. And so I had a lot of trouble doing the physical construction of this robot. I didn't know where to start at all, and I was looking at all of these crazy industrial type arms, and I was like, how am I gonna build this? They look so fancy and cool. But I did it. I used some 3D modeling. I took out some like friendly wood, and it came together. And that was a really, really valuable experience, because just playing on your laptop isn't as fun as making something that people can see and is useful. So being able to marry those two disciplines and marry those two valuable things means that I can make something even cooler, even more valuable in the future, which I'm really excited about. So I'm really happy that I did this project, because that puts me on the track for much better and